Good morning all. Now I am going to explain about some numerical problems on series resistor and series inductor and series capacitor when it is connected to AC voltage. Okay. First problem, calculate average value, RMS value, form factor, peak factor of an alternating quantity. Okay, the instantaneous value of voltage is 200 sin 314 t. Okay, what is asking? Calculate average value, RMS value, form factor, peak factor of an alternating quantity. Alternating quantity or alternating voltage or alternating current is nothing but AC, right? Sometimes he may mention AC voltage or sometimes he may mention sinusoidal voltage. Okay, both are same. That means already we know for a sinusoidal voltage average value formula, RMS value, form factor, peak factor, right? Okay, now see here what is given. First you have to write given data. Okay, in this given data instantaneous value is given, V is equals to 200 sin 314 t, right? Okay, compare with the standard equation, that is V is equals to Vm sin omega t. Okay, if I compare with the standard equation, Vm value is 200 volts. Okay, in case of a sinusoidal waveform, average value formula will be 2 Vm by pi. Here Vm value is 200, that is 2 into 200 by pi. If I simplify this equation, I will get average value is 127.3 volts. Okay, after that RMS value is equals to Vm by root 2. Already we know Vm value, right? Substitute here, you will get 200 by root 2. Then RMS value will be 141.4 volts. After that form factor. Form factor is equals to RMS value divided by average value. That is RMS value is 141.4, right, and average value is 127.3, then form factor is 1.11. Similarly peak factor is equals to maximum value divided by RMS value, right? Maximum value is 200 and RMS value will be 141.4, then you will get peak factor as 1.414. okay, this is one problem. Okay, this is based upon a sinusoidal voltage and AC voltage. Okay, now we will solve problem on resistor and inductor and capacitor. Okay, see here an AC circuit consisting of a pure resistor having a resistance of 20 ohm is connected across an AC supply of 200 volts, 50 Hz. Okay, calculate what is the first bit, current, second bit is power consumed, third bit is write down the equations for voltage and current. Okay, first write the given data. What is given? Resistance value is given. See here, unless otherwise specifically mentioned, the mentioned voltages and mentioned currents are RMS values only. Okay, that means here AC supply voltage of 200 volts, 50 Hz is given, right? That is nothing but RMS value of voltage. Okay, VRMS is equals to 200 volts. Okay, frequency F is equals to 50 Hz. Okay, based upon this given data I can draw the circuit diagram, right, like this. Okay, after that already I know VRMS value and resistance value, right? Then I can easily calculate current. See here, current also not mentioned means that is RMS current, that is IRMS is equals to VRMS by R, that is 200 by 20, that is equals to RMS value of current is 10 amperes. Next, power consumed, right? Already we know in case of pure resistor power consumed formula will be in terms of RMS values VRMS into IRMS, okay, or Vm Im by 2 in terms of maximum value and maximum value of voltage and maximum value of current, right? Then power consumed will be 200 into 10, you will get 2000 watts. Third bit, write down the equations for voltage and currents. See here, voltage equation is V equals to Vm sin omega t. Current equation is I is equals to Im sin omega t. That means here I need to calculate Vm and Im, right, to write the equations. That means by using these two formulas, VRMS equals to Vm by root 2, IRMS equals to Im by root 2. First of all I need to calculate Vm value and Im value, right? That is Vm is equals to root 2 into VRMS. Okay, similarly Im is equals to root 2 into IRMS. Then I will get Vm value as 228.28 volts, Im value as 14.14 amperes. After that I need to calculate omega, right? Frequency F is given, right, in the given data. Okay, that means omega is equals to 2 pi into F. that is 2 into 3.14 into 50, that is equals to 314 radians per second. Then the instantaneous value of voltage and current equations are V is equals to, V value will be 228.28 into sine 314 t volts. Current I is equals to 14.14 into sine 314 t amperes. Okay, similarly we can solve one problem on inductor. A pure inductive coil allows a current of 10 amperes to flow from a 230 volts, 50 Hz AC supply. Okay, calculate inductive reactance first bit, second bit inductance of your coil, third bit power absorbed, fourth bit write down the equations for voltage and current. Okay, based upon this given data, let us consider a inductor having inductance L. The current flowing through the inductor is 10 ampere, right? To flow from a 230 volts, 50 Hz. That means supply voltage is also given. That means from this given, what is given? Current is nothing but IRMS current. Unless otherwise specifically mentioned, means those values are RMS values. IRMS equals to 10 amperes. VRMS is equals to 230 volts. Okay. Frequency F is equals to 50 Hz. Okay. Already we know that what is the first bit I need to calculate inductive reactance, right? Voltage across the inductor formula is V is equals to I into XL. V value is known, I value is known, right? From this equation I can calculate inductive reactance. That is inductive reactance XL is equals to V by I. Actually in case of inductor you have a formula VL is equals to plus J into I into XL. Here I am considering only magnitude. Okay. After that XL is from this equation XL is equals to V by I, that is equals to 230 by 10. This XL value will be 23 ohms. Similarly, inductance of a coil, I need to calculate XL. Already we know that inductive reactance formula XL is equals to omega L, that is equals to 2 pi F into L. Right? From this equation L is equals to XL by 2 pi F. XL value is 23. 2 pi F value is 2 into pi value will be 3.14 into frequency is 50 Hz. If I solve this equation, L value will be 0.073 Henry. Okay, what is the third bit? Power absorbed is 0. In case of inductor, already we know, right? Average power will be 0. Next, write down the equation for voltage and current. Already we know instantaneous value of voltage equation is Vm sin omega t. Instantaneous value of current is Im sin omega t minus 90. Okay, from this equation, first you need to calculate. Already you know VRMS and IRMS, right? First calculate Vm and Im, substitute here, you will get instantaneous values of voltage and current. Okay, thank you all.